Welcome to BSc Main Physics, Semester 6, Paper 1, Solid State Physics, and today the class is S23, Problems on Electrical Conductivity. Problems on Electrical Conductivity, Unit 2, Conduction in Metals. We continue. Semester 6, BSc Main Physics. And here is the first problem. I shall read the problem. The first problem. A copper wire of radius 1.5 millimeter carries a current of 10 ampere. Find the current density and electric field strength in the wire and also find the drift speed of electrons in copper. Resistivity is equal to 0.0172 micrometer and N equal to 8.43 into 10 raised to 28. I shall read the problem. A copper wire of radius 1.5 millimeter carries a current of 10 ampere. Find the current density and electric field intensity or strength in the wire and also find the drift speed of electrons in copper. Resistivity equal to 0.0172 micro ohm meter and N is 8.43 into 10 raised to 28. ഇപ്പോൾ ഒരു കോപ്പർ വയറുണ്ട്, റേഡിയസ് 1.5 മില്ലിമീറ്റർ ആണ്. അതിനകത്ത് ഒരു 10 ആമ്പിയർ കറണ്ട് കടന്നു പോവുകയാണ്. കറണ്ട് ഡെൻസിറ്റി കണ്ടുപിടിക്കാനാണ്. അതിനൊപ്പം തന്നെ ഇലക്ട്രിക് ഫീൽഡ് സ്ട്രെങ്ത് കണ്ടുപിടിക്കണം. അപ്പോൾ രണ്ട് ഡേറ്റ തന്നിരിക്കുന്നത് ആ വയറിൻ്റെ റെസിസ്റ്റിവിറ്റി, കോപ്പർ വയർ റെസിസ്റ്റിവിറ്റി അതുണ്ട്. അത് മൈക്രോ ഓമിലാണ്. ഓമാക്കി മാറ്റണം, ഓം മീറ്ററാക്കി മാറ്റണം. അതുപോലെ ഇലക്ട്രോൺ ഡെൻസിറ്റി, നമ്പർ ഓഫ് ഇലക്ട്രോൺസ് പെർ യൂണിറ്റ് വോളിയം, ഇലക്ട്രോൺ ഡെൻസിറ്റി അത് നമുക്ക് തന്നിരിക്കുന്നത് 8.43 ഇൻറ്റു 10 raised to 28 എന്നാണ്. അപ്പോൾ നമുക്കതൊന്ന് ആ പ്രോബ്ലം സൊല്യൂഷൻ നോക്കാം. J is I by A, that is current density. I by A, I is 10 ampere, A is pi r square. Radius is 1.5 millimeter. We convert into meter. 1.5 into 10 raised to minus 3 the square. It is equal to 1.4147 into 10 raised to 6 ampere meter raised to minus 2. And in this problem, we have to put pi equal to 3.14. Then only we get the answer. Electric field strength is J by sigma. We apply the point form of Ohm's law. J is sigma E. And also sigma is 1 by rho, where rho is the resistivity. So we can find sigma using 1 by rho, that is 1.0172 into 10 raised to minus 6. That is equal to 58.139 into 10 raised to 6 Siemens meter raised to minus 1. Ohm meter raised to minus 1 is also called Siemens. Remember, this is capital S, not a small s. If it is small s, we read as second. If it is capital S, we have to read as Siemens. Here it is capital S, which is actually ohm raised to minus 1. So, sigma is equal to 58.139 into 10 raised to 6 Siemens meter raised to minus 1. Now E is equal to J by sigma equal 1.4147 into 10 raised to 6 by 58.139 into 10 raised to 6. That we get equal to 0.024 volt per meter. Unit of E is volt per meter. Then current density J is NeV. Therefore, drift speed J by Ne. J is 1.4147 into 10 raised to 6. And N is 8.43 into 10 raised to 23 into E, electronic charge, 1.6 into 10 raised to minus 19. We get 1.048 into 10 raised to minus per meter per second. You see the order of drift velocity. It is very small. The drift velocity of electrons in the conductor, copper conductor, is very small, of the order of 10 raised to minus 6 meter per second. I told you early in the earlier class, drift speed is small. Next problem number 2. Calculate the conductivity of copper if collision time is 10 raised to minus 15 seconds. You read as 10 raised to minus 15. It is raised to written in that manner. Calculate the conductivity of copper if collision time is 10 raised to minus 15 second. Assume that copper has simple cubic structure with a lattice parameter 4 angstrom. Also calculate the resistivity of copper. Also calculate the resistivity of copper. ഇവിടെ കണ്ടക്ടിവിറ്റിയും കാണണം റെസിസ്റ്റിവിറ്റിയും കാണണം. ഇപ്പോൾ കണ്ടക്ടിവിറ്റി കാണാനായിട്ട് നമ്മുടെ യൂഷ്വൽ ഇക്വേഷൻ നമ്മൾ ലോറൻസ് ഡ്രൂഡ് തിയറിയിൽ പഠിച്ച ഇക്വേഷനാണ്. To find conductivity, we apply the Lorentz-Drude relation for conductivity. That is, conductivity sigma is any square tau by m star. ഈ ചില ബുക്ക് നോക്കുകയാണെങ്കിൽ ഇൻ സം ടെക്സ്റ്റ് ബുക്ക് ഇറ്റ് ഈസ് റിട്ടൺ ആസ് സിഗ്മ ഈസ് any square tau by 2r. This 2 comes because when we take a velocity as average 0 plus v by 2 in that manner. In some textbooks you do like this. It is also given in books. There is some difference when we refer different books. Conductivity sigma is any square tau by m star. M star is the effective mass of electron in the conductor. N number of electrons per unit volume. Here unit cell volume, this is a simple cubic crystal. Unit cell volume is V is A cubed, the lattice constant, the lattice parameter, lattice spacing and lattice parameter equal in unit cube. So V is A cubed, volume of unit cell is A cubed. And you remember, unit cell contains one electron as per the question. Unit cell contains one electron, so we can write number of electrons in A cubed. That is unit cell volume. Number of electrons in A cubed in unit cell volume is equal to 1. ഒരു യൂണിറ്റ് സെല്ലിൽ ഒരു ഇലക്ട്രോണാണ് ഉള്ളത്. So what is number of electrons in 1 meter cubed? Number of electrons in 1 meter cubed, we have to divide 1 by that unit cell volume. 1 by A cubed. N is 1 by A cubed. A is 4 angstrom, therefore we write as 1 by 4 into 10 raised to minus 10 cubed. That we get 1.56 into 10 raised to 28 per meter cubed. That is the electron density. And tau, the collision time, is 10 raised to minus 15 second. M star, effective mass, nothing separately given, so we can write M star is actual the rest mass of electron, that is m 9.1 into 10 raised to minus 31 kilogram. We substitute. That is sigma is equal to any square tau by m star equal to 1.56 into 10 raised to 28 into electronic charge, 1.6 into 10 raised to minus 19, the square into 10 raised to minus 15 by 9.1 into 10 raised to minus 31. We get 0.44 into 10 raised to 6 ohm raised to minus 1 meter raised to minus 1. That is the answer. Now comes resistivity rho. 1 by sigma. That is 1 by sigma is 1 by 0.044 into 10 raised to 6, which is 2.27 into 10 raised to minus 6 ohm meter. Answer. Next problem number 3. There are number of problems. You can expect one. The density of a piece of metal of atomic weight 60 is 5,000 kilogram per meter cubed. Find the number of electrons per unit volume if every atom contributes one free electron. The density of a piece of metal of atomic weight 60 is, atomic weight is 60 is. Atomic weight 60 is 5,000 kilogram per meter cubed. Find the number of electrons per unit volume if every atom contributes one free electron. ഒരു ആറ്റം ഒരു ഫ്രീ ഇലക്ട്രോൺ കോൺട്രിബ്യൂട്ട് ചെയ്യാണ്. One atom contributes one free electron. So to find the number of free electrons, we have to find the number of atoms per unit volume. Number of atoms per unit volume we have to find, and that is the number of electrons per unit volume. Remember. Number of electrons per unit volume. That is number of atoms per unit volume. You remember that is small n is n by V, where V is the molar volume and n is Avogadro number. You know, in molar volume there are n atoms. Here it is n electrons. Each atom contributes one electron. So we write n is capital N by V. V is molar volume and n Avogadro number. And what is volume? Volume is mass by density. Here we have to take a molar mass. The gram molecular mass we have to take. So that we put there n is capital N by m by rho. That is n is n rho by m. N rho by m. This formula is very important. When you are asked to find the number of atoms per unit volume, you can directly apply this formula. When you are asked to find the electron density, you can apply this formula directly. This is the number of electrons per unit volume if one atom contributes one electron. N rho by m. N Avogadro number, D density, and m is the molar mass. Molar mass first expressed in gram and then converted into kilogram. It is equal to n 6.023 into 10 raised to 23, and rho is 5005 into 10 raised to 3, and molar mass m is given m is 60 gram, and when we convert it into kilogram, we get 60 into 10 raised to minus 3. The answer works out as 5.02 into 10 raised to 28. That is the electron density. Next problem. Copper has a mass density rho m, that we can take as rho 8.958 gram per centimeter cubed, and an electrical resistivity rho is 1.55 into 10 raised to 8 minus 8 ohm meter at room temperature. Assume that effective mass m star is m0, rest mass. Calculate the concentration of conducting electron and a mean free time tau. You look here, copper has a mass density rho m is equal to 8.95 gram per centimeter cubed, and an electrical resistivity rho is 1.55 into 10 raised to minus 8 ohm meter at room temperature. Assume that the effective mass m star is m0. Calculate one concentration of conducting electron to the mean free time tau. So we do the problem as follows. Here, number of electrons in 1 meter cubed, we apply the formula directly. N rho by m, that is 6.023 into 10 raised to 23 into 8.95 into 10 raised to 3. And here, the molar mass 64 into 10 raised to minus 3. The answer is 8.42 into 10 raised to 28. 28 per meter cubed, that is n. Mean free time, and for that we apply the conductivity relation. The conductivity relation we apply, that is sigma is n square tau by m star. M star is m itself, the rest mass we can take. And from that, if we find tau, we get tau is equal to m star sigma by n square equal 9.1 into 10 raised to minus 31 into sigma, which is 1 by rho, 1 by 1.55 into 10 raised to minus 8, and n is 8.42 into 10 raised to 28. E square also you have to write into 1.6 into 10 raised to minus 90 square. On simplification, we get 9.1 into 10 raised to minus 13 by 8.42 into 1.6 square into 1.55. That is 0.272 into 10 raised to minus 3 equal to 2.72 into 10 raised to minus 14 second. 2.72 into 10 raised to minus 14 second, that is the answer. That is the mean collision time. Next problem. Question number 5. The PD across a wire of 10 to minus 6 centimeter square cross-sectional area and 50 centimeter length is 2 volt. When a current of 0.25 ampere flows in the wire, find 1, the field strength in the wire, 2, current density, and 3, conductivity of the wire. You see the problem? The PD across a wire of 10 raised to minus 3 centimeter square cross-section area, cross-sectional area, and 50 centimeter length is 2 volt. The PD applied is 2 volt. The PD applied is 2 volt. When a current of 0.25 ampere flows in the wire, find the field strength in the wire, the current density, and the conductivity of the wire. Electric field is V by D. That is 2 by 0.5. That is 4 volt per meter. J is I by A, 0.25 by area, 10 raised to minus 3 into 10 raised to minus 4. J is I by A. I is 0.5 ampere. What is area? Area is cross-sectional area. Cross-sectional area is 10 raised to minus 3. So 10 raised to minus 3 centimeter square, we have to convert it into meter square. 1 centimeter square is 10 raised to minus 4 meter square. That is why 10 raised to minus 4 is coming in the denominator. So we get I is equal to 2.5 into 10 raised to 6 ampere per meter square. Ampere per meter square. Conductivity sigma question mark. J is sigma is J by E, that is 2.5 into 10 raised to 6 by 4, 25 by 4 into 10 raised to 6. 10 raised to, you see the value? 2.5. 2.5 by 4 into 10 raised to 6. 2.5 by 4 is not 25, 2.5 by 4. That is 0.625. 0.625 into 10 raised to 6. Ohm raised to minus 1, meter raised to minus 1. That is conductivity. The second step, sigma is J by E, 2.5 into 10 raised to 6 by 4. Next step is not required. Last step, 0.625 into 10 raised to 6. Ohm raised to minus 1, meter raised to minus 1. Now we can see problem number 6. A metallic wire 1 millimeter diameter carries a charge of 100 coulomb. C, it is capital C. 100 coulomb in the coulomb in 1 hour. Coulomb in 1 hour or per hour. Coulomb in 1 hour. The metal contains 6 into 10 raised to 22 free electrons per cubic centimeter. Calculate the current in the wire and the drift velocity of the electrons. Current in the wire and drift velocity of electrons we have to find. You see the problem? A metallic wire 1 millimeter diameter carries a charge of 100 coulomb in 1 hour. The metal contains 6 into 10 raised to 22 free electrons per cubic centimeter. Calculate the current in the wire and the drift velocity of the electrons. So we can find the current first. I is Q by T, charge by time. 100 by here it is given 1 hour, that is 16 to 60 seconds. We get 1 by 36 ampere. That is the current, 1 by 36 ampere. 1 by 30 ampere, N is 6 into 10 raised to 22 per centimeter cubed. And we have to convert into meter cubed by multiplying it by 10 raised to 6. 1 meter cubed is 10 raised to 6 centimeter cubed. Here it is per centimeter cubed. So to convert to centimeter cubed to meter cubed, we have to divide it by 10 raised to minus 6. So 10 raised to 6 plus 6 will come in the numerator. We get N is 6 into 10 raised to 28. അവിടെ സംശയമൊന്നും ഇല്ലെന്ന് ഞാൻ വിചാരിക്കുകയാണ്. സെൻറ്റിമീറ്റർ ക്യൂബിനേക്കാൾ എത്രയോ വലുതാണ് മീറ്റർ ക്യൂബ് എന്ന് പറയുന്നത്. 10⁻6. അപ്പോൾ 6 കൊണ്ട് ഗുണിക്കുക എന്നുള്ളതാണ് അവിടെ ഐഡിയ. 10⁻28. I is NEVA. Current is NEVA. B is I by NEA. I by NEA. That is 1 by 36 into 6 into 10⁻28. Current is written, then 6 into 10⁻28 into 1.6 into 10 raised to minus 19 into area pi r square. Pi into 0.5 into 10 raised to minus 3 square. That is 10 raised to minus 3 by 86.4 equal 1.1157 into 10 raised to minus 5 meter per second. That is the drift speed. You note the drift speed is small, 10 raised to minus 4 or minus 5 order. In this problem, we get a 10 raised to minus 5 order. So that is all with your 23rd lecture on conduction on solid state physics, and we continue our class with the residual resistivity. That is the topic in the next class. Thank you very much.